Hello students, today I am going to teach you correlation. We see how correlation is useful, what are its definition, what is its type, and we see a very important method where you are going to use this all the information to solve the examples. Okay, let us start without wasting your time. Immediately, if you like this video, please like and subscribe. If this video gets at least 10 likes, I will make immediately the next example video. Okay, here we start. In today's data science world, we come across many activities which are dependent on each other. Yes friends, so like you are dependent on someone, you are dependent on your parents, you're dependent on teacher, so you are going to depend on someone, and with this you can see there will be a dependent variable. Then there are some things which are independent variables, that is like exam, it's a independent, just you have to appear for the exam and you have to be studying, practicing the problem. So like this, exam is a independent variable, whereas parents, they are independent variables. So like this, in maths we see large number of problems involving the uses of two or more variables. Identifying these variables and its dependency helps us in resolving the many problems. So you can see many times there are problems or situations or where two variables seems to move in the same direction, such as both are increasing or decreasing. Yes, one you can say increasing and another there is decreasing. Depending on this, we are going to choose the variable. At times, as increases in one variable is accompanied by decline in other. Yes, friend. Now you can just see you were studying in some 10th and you are now completed, so it is finished. You are going to go to the PUC or diploma, again you complete there, and now you are going to study the degree. So here we come across engineering degrees there, BA is there, BCom is there, any degree you are going to come. So it is going to, one will stop and decline and it will go to the next one, then again you have to increase. So for example, family income and expenditure is there, price of the production and demand is there. So one is, another one is that it is demand and product, how they are going to come up. And then we have advertisement expenditure and sale volume. If two quantities, what we have taken previously, vary in such a way that the movements in one are accompanied by movement in the other, then these quantities are called to be correlated. That's very simple. So here we can see very easily how they are correlated. Yes, your parents and yourself, you are correlated. Your studies and your examination, they are correlated. So like this, everything is correlated to each other. So let us go to the one of meaning, very important. Correlation is statistical techniques to assert the association or relationship between two or more variables. Correlation analysis is a statistical technique to study the degree and direction of relationship between two or more variables. Yes friends, very simple this is. Here we can see the correlation. When we come across statistical measures, we see this correlation coefficient is a statistical measure of degree to which changes to the values of one variable predicted chances to the value of another. When the fluctuation of one variable reliable predicts a similar fluctuations in other variable, there is often a tendency to think that means that the change in one causes the change in the other. Yes friends, So like this, we take the change in one to change in other. So here some of the uses we are going to take. So uses we have seen, correlation analysis helps in deriving precisely the degree and the direction of such a relationship. Yes, friends, here we can see how degree is there. So as you have degree, you get the direction. Suppose you have completed BCom, you get the direction in computing, banking is there, some other sectors like, and then if you do science, then you come across lot of other sectors. Suppose you have done diploma, you'll come other engineering sectors. If you have done medical, you'll get the degree in directions in medical. So if you have done engineering, so you'll get the direction in that. So like this, whatever degree you have, you will get that. Similarly the jobs, what that you prefer moreover jobs. So if you are engineer, definitely you'll get an engineering job. If you are lawyer degree, if you have a lawyer degree, you will get a job in law. So this is, they are all correlated. The effect of correlation is to reduce the range of uncertainty of our prediction. So like this, we just predict that the things, when we study one degree, we get the direction. The prediction based on correlation analysis will be more reliable and nearer to reality. Yes, here what is important is that whatever the we are going to predict, how we are close to the point. Suppose we predict for any exam, any competitive exams, or your government exam is there, your seat is there, entrance exams are there, you're predicting you get more and more marks, but correlation says how much you are going to predict and how much is the reality. That is important. Suppose you don't study for the examination and you are predicting that I'm going to pass in the exam. No. So remember this. When you study, when you practice the problems, when you come to the conclusions, when we remember all the formulas, definitely you are going to pass in the exam. That is our prediction. Remember this, students. Very, very important. Correlation analysis contributes to the understanding of economic behavior, aids in locating the critical important variable on which other depend, may reveals to the economist the connections by which disturbance spreads, and such to him the path through which stabilize forces may become effective. Thus suggest, so like this you can see as from, so many correlation analysis are there. Economic theory and business studies shows relationship between variables like price and quantity, demanded advertising expenditure and sale promotion, etc. The measure of coefficient of correlation is relative measure of change. Yes, friends, very very important. You can see even stress and strain, they are measures of changes, and you can see they are correlated. So like this we get lot of technical examples, non-technical examples we get in correlation. So here are the very important types of correlations. Please remember this one. There are only three types. What it describes, how it is classified. Yes, first type says that it's positive and negative. Second type simple, partial and multiple. Third one is linear and non-linear. So all the definitions I'm going to give you students. If you subscribe this video, if you subscribe the channel, and if you like this video, at least 10 students, if they like this video, whatever the notes are there, I'm going to post in the description box. Is it clear? So remember this, and I'm going to solve the examples on all this in my video on my YouTube channel. My YouTube channel, Engineering Mathematics Made Easy for All. We get the all the notes. I have given the question paper. I have also uploaded the books, some of the books, and whatever the notes I prepare, I always upload it in the description box, friends. Please go to the description box, you can see the playlist, all the definitions, you can easily write it down. Suppose the positive correlation is there, so what it says, if both the variables vary in the same direction. Yes, very very important. Suppose you have studied hard and you have practiced the problems, definitely if you get the good result, means it is a positive correlation. It means if one variable is increasing, the other one, an average, is also increasing. If one variable is decreasing, the other average is also decreasing, then the correlation is said to be positive. So like this, we have the positive correlation. Similarly, you can see the definition of negative correlation. If the both variables vary in opposite direction, suppose you have hard studied, you practice the example, still your result is not good or you have failed in the exam, means that negative correlations. The correlation is said to be negative. It means if one variable increases but the other variable decreases, or if one variable decreases the other variable is increases, then the correlation is said to be completely negative. Yes friends, here we have the next definition, very very simple. Zero correlation. Yes friends, here we see the zero correlation. What is there in this zero correlation? Yes, actually it is not a type of correlation, but still it is called zero or no correlation. So there are some correlations, or there are some relations, there is no comparison between two. When we don't find any relationship between the variables, then it is said to be zero correlation. It means that the change in the one variable doesn't influence or change in the other variable. So therefore we take it as a no correlation. Like you are intelligent and weight. Suppose your weight is more. Suppose your weight is more. It means that you are more intelligent. It is not possible. Right. Suppose you are very very thin. Right. Means that you are no. You are very very intelligent. No, it doesn't mean like that. So like this, there is no relation with this. So we say it as zero correlation. The second type is simple, partial and multiple correlation. Very very important, and you can see many questions will come in the exam considering these three correlations. Yes, what is simple correlation? When one variable are studied, it is a case of simple correlation. Means only one variable we study. Suppose if you take x variable, only x we are going to study. If you take only y variable, you are going to study only y variable. That is called simple correlation. Is it clear, friends? Similarly, next we have partial correlation. In case of partial correlation, one studies three or more variables, but consider only two variables to be influencing each other, and the effect of other influencing variables being held constant. Means there are x and y is a variable, x varies, y varies, y varies, x varies, but if you take z, it doesn't affect x and y. Therefore z, we just take one example I am giving, z is to be set as constant. This is how we say it as constant variable. Next we have multiple variable. Now here you can see one more example in partial correlation. I remember just now. In the above example of relationship between, you can see the student's marks and the attendance. If you attend all the classes, definitely you'll get the good marks. The other variable influences, such as effective teacher, teaching of teacher, use of teaching aids like computer, smart board, etc. is assumed to be constant. Yes, sir. This is very very important. You can see if you attend and you'll get the good marks. But some of the things like you are going to use the presentation or the computer or smart boards, if you use, they consider it to be constant. Means there is no much effect on studies. Suppose there are some videos, good videos are there, bad videos are there, which is going to come in the exam is more important. Again, all these things will remain constant because you have to study, you have to write the exam. So that is correlated. Yes, multiple correlation. Here we also take it as two or more variables are studied. Means suppose there are three variables x, y, z. All three variables we study at a time, and we come to the conclusion. This type of correlations are known as multiple correlations. Suppose the relationship between student marks, attendance of students, effectiveness of teacher, use of teaching aids, etc. All these are involved in study. Then we say this type of case study is a multiple correlations. So this is how we have the all the three all the types of correlation. Next, last, yes students, we'll finish this lecture. Linear and non-linear correlation. Yes students, what is linear? If the amount of change in one variable bears a constant ratio to the amount of change in the other variable, then correlation is said to be linear. If such variables are plotted on graph paper, all the plotted points would fall on a straight line. Yes friends, if you take any points, number of points you take, any points, when we fit it on a straight line and all this are in this straight line, then we say these points are to be linear correlation. This is very very important. If suppose the amount of change in one variable bears a constant ratio to the amount of change in the other variable, then correlation is said to be linear. Suppose you are going to take a plotted on a paper, just you take all the plotted points, such falls on the straight line. It is assumed that to produce 1 unit of finished product we need 10 units of raw materials. Then subsequently to produce 2 units of finished product we need to be double of the 1 unit. So this is how we can say this is linear correlation. Yes friends, last correlation here we have, that is non-correlation. Yes friends, here we can see if the amount of change in one variable does not bears a constant ratio to the amount of change to the other variable, then correlation is said to be non-linear. If such variables are plotted on graph, the points would fall on curves and not a straight line. Means there are many points, you take number of points and you just plot the graph. You can see whatever the graph you have plotted will not be a straight line, it will be some zigzag curve. When you plot it and connect all the points, it will be in the zigzag curve. Such correlation we can take it as a non-linear correlation. Yes friends, this is what we have completed the types of correlations. Next we just see, based on this we'll go to the examples. Yes, I've just collected few examples so that your brainstorming will be done. You can see, state in each case whether there is positive correlation, negative correlation and no correlation. Yes, we see some examples. I have collected three things will identify: positive, negative, no correlation. Let us start. Okay, you can see particular solution, price of commodity and its demand. Yes, it is negative correlation. So some more examples I have collected. Yield of crop and amount of rainfall. Yes, it is a positive correlation. So how much rain falls, that much crops grow. When crops grow, because rainfall is more, they are positive correlation. Number of fruits eaten and hungry of a person, yes, it is a negative correlation, because how much you number of fruits eaten, so you can, there is drop in the fruits, so hungry is also drops, no, hungry will increase, so there is a negative correlation. Now in the next example, you can see number of units produced and fixed cost per unit, it is also negative, means you have used some electricity and units have increased. If units of the electricity in your at home, what is the electric bill is there, in that if units are increased, cost, fixed cost will not increase. They have fixed per unit, cost is fixed. So this is no negative correlation. Number of girls in the class and marks of boys, no correlation. How many girls are there, that much marks you'll get, 9. How many boys are there, that much marks you'll get, 9. So there is no correlation. Age of husband and wife, yes, positive. If age of husband increases, automatically age of wife increases. Please say they never decreases. Temperature and salt of wooden garments, yes, it is negative, because temperature increases, sale of the wooden decreases. So they are opposite to each other, right? If the suppose the temperature decreases, like 10 degrees there, 5 degrees there, it is decreasing, temperature is decreasing, you feel cold, so you collect, you buy garments. So woolen garments like sweater is there, you buy more, so they are opposite to each other. Number of cow and milk product, yes friends. So if cow, number of cow increases, like 10, instead of 10 there are 20 cows, 30 cows, 40 cows, 50 cows, then you can see milk production also increases. Suppose 10 liter, 20 liter, 50 liter, 100 liter, they are positive correlated. Weight of the person and intelligence, just now we discussed, if the weight of the person increases, you think that intelligence increases? No. If the weight of the person decreases, intelligence increases. There is no correlation between weight of the person and intelligence. Then next, last, we have the advertisement expenditure and sale volume is positive. How much you advertise, you can see in the sale product increases. So this is a positive correlation. So next, just missed one slide. Yes. Next we have methods of measurement of correlation. So how many methods are there? Yes. So we have divided into two parts. Okay. So here I will see quantification of a relationship between variables is very essential to take the benefit of study of correlation. For this we find there are various methods of measurement of correlation which can be represented as given below. So you just take the methods of measurement of correlation. There are two types we have taken. One is graphical method is there and algebraic method. So graphical method, you can see a scatter diagram they give, and if in this diagram, if the points are scattered in x-axis only in one direction, then we say it is a no correlation. If the scattered line increases from bottom to up, then we say it is a positive correlation. If the scattered points comes from top to bottom, we see it as negative correlation. Suppose in the graph x and y axis, the line is drawn from initial point to the upward direction, we say it as a positive correlation, and from same line if comes from top to down, we take it as a negative correlation. So this is graphical. We don't much study about graphical, but we study more about algebraic methods. So here we can see in algebraic methods, friends, Karl Pearson coefficient of correlation is very important. So this is first algebraic method we study, and I'm going to solve the example on this. If I get at least 10 likes for this video, I'm going to make the next video immediately on the method, very important algebraic method, Karl Pearson coefficient of correlation. The next one we have Spearman's rank coefficient of correlation. Then we have concurrent deviation method, method of least square. So these are all methods of algebraic methods of correlation. Yes, friends. So this is what we have the methods. Next, we'll see the Karl Pearson coefficient of correlation. So this I'm going to discuss in the next video. Yes, thank you so much, friends. Thank you for watching till the end.